CUM is an online tool that allows different stakeholders to evaluate complex modeling results using multi-criteria decision analysis techniques and share various data with different type of permissions. The CUM tool is user-friendly. A tutorial has been provided to guide the user through the main working procedures in the tool. First of all, the user should sign into the platform. To view the study regions for GoCUM project, use the link Study Areas in the menu bar in the header. You will get an overview map for the available study areas. These areas are represented on the map by colored rectangle. By clicking on each one, you will get pop-up box. In this pop-up, you can click on the shown picture to see more details for the area, and to have the possibility, either to begin and run a new calculation, or to explore the saved calculation results. To run a new calculation and save the result, we should first select a scenario. Now by clicking on the button Scenarios, a list of cards will appear. Each card is actually an available scenario for the selected area, including all the related information. After selecting a scenario, a table will be shown. Each row represents a provided indicator. You can get short description for every indicator by hovering your mouse on it. Here you can select one indicator or more by ticking the checkbox in front of every indicator. Once an indicator is selected, one function can be assigned to it. The function select options contains two menu. Default function. This menu contains just one function, which is defined by default by administrator. The second menu is your functions, which contains a list of your own defined functions.
It's worth mentioning that in CAM, there are two cases for the function with spatial distribution. The study area in this case has been divided to multiple sub-areas. Each one has its own parameters for the function without spatial distribution. The study area in this case has just one sub-area, which is identical to the study area. If a function with spatial distribution has been chosen, a window will display. On the left side, the spatial distribution of the selected function is presented. For each sub-area in the study area, different parameters have been defined. The selected function will be applied on the selected indicator. Consequently, this indicator with predefined legend will be presented on the right side. By clicking one of the spatial areas in the legend of the spatial distribution of target function located on the left side, you will see in the middle a diagram with parameters belonging that area. Accordingly, the defined parameters of this sub-area will be performed only on the indicator's pixels located in that sub-area, which will be highlighted. You can change the parameters of the selected default function by dragging the points in the diagram. These changes will be implemented on the selected indicator and the result will be previewed on the fly on the right side. You can switch the view of the indicator to the whole area as well. These function can be modified additionally by mouse right-click and entering the parameters. The same thing, the indicator will be viewed on the right side and you can check if the whole area has been updated as well. The selected indicator should be weighted by a value between 0 and 1. As we said, an individual scenario is represented as a collection of indicator rasters. That means, multiple indicators can be chosen and considered for our evaluation. We do the same step for every selected indicator, assigning a function and customizing it, weighting the indicators. But we should take into consideration that the sum of weighting values for the selected indicators must be 1. Otherwise, we will not be able to continue the process. Now we can choose the method, composite programming, to perform it on the calculation. After we've finished the selection of the available options previously, we can run our calculation by just clicking on the button, Calculate. Consequently, we will get a window, which includes a preview for the calculation result. In order to save your result, a name and a short description should be input and then click Save. Accordingly, the result will be published as web services and the related information will be saved in CAM database. To browse your stored results and analyzed it, go back to the selected study area and explore your calculations. Each one will be shown including thumbnail, name, short description and the created date. Here you can update the name and description for each calculation. Or you can delete it. You can set permissions and you can view the calculation in a GIS viewer. Moreover, two calculations can be compared.
You have the possibility as well to get more information about your result knowing which indicators have been used in every calculation result. which functions and weighting values have been assigned for every indicator in the concerned calculation. In which scenario the calculation has been run, you can assign the permissions for your result to specific users. You can also assign it to a group, and when you do that, all the group members will have those permissions. You can select the calculation by toggling the checkbox on the right bottom corner for every calculation result, to view it in a WebGIS viewer, where you can analyze it. As we said, two calculations can be compared. To do that, we select two of our results and click on Comparison. The first result on the left side and the second result on the right side. Regarding the indicators involved in the calculation procedure, a background process has been implemented to upload it into the platform. The project areas, the concerned scenarios and indicators with its default target function should be first defined on the CUM platform. These data will be written into the down directory on the cloud, where the data between the CUM platform and CumUp can be exchanged. CumUp is a software which is used for preparing and creating modeling results, which will be represented on the platform as indicators. CumUp will be connected to the cloud. This cloud has three directories: down, settings, up. Down contains data handled by the CUM platform and imported by CumUp. Settings contains default settings used by CumUp which are allowed to be changed by user. Up contains indicators created by CumUp, ready for exporting to the CUM dialog platform. Accordingly, CUM will read the directory up, upload the new created indicator raster into the system and set the necessary configuration to be displayed and processed properly. The layers on the platform are published resources, representing raster or vector spatial data. A wide range of documents types are allowed on the platform, including text files, spreadsheets, images, videos, PDF, which can be easily uploaded to the platform. It is also possible to register external map services, using OGC standards, to load remote layers into the platform. We can also browse maps by clicking the Explore Maps link. This will bring up the list of the available maps on the platform. In order to create new maps, click on the Create Map link in the navigation bar. This will open a map viewer. A map can be created using the uploaded layers in the system or the remote layers served from other web map services. Select the wanted layers and add it to the map. Click on the Map button in the toolbar, and select Save Map. Enter a title and abstract for your map. Once your account is created, the People link will enable you to see a list of registered users on the platform and their information. Likewise, all the platform group profiles can be viewed. For each group, some summary information such as the title, the description, the number of members and managers are displayed near the group logo. Here the administrators can manage their groups. To encourage the dialogue between different stakeholders, the results of two users can be analyzed side by side. To do that, we need to enter the dialog page by using the link dialog in the menu bar in the header. Click on the button Start Dialog on this page, will direct you to an overview map for the available study areas. After selecting a specific study area, a list of the available users' income will appear. When you choose one of the listed users, you will be redirected to another page. On the left side of this page, a list of your calculation results will be shown. On the right side, a list of the calculation results for the selected user. Only the calculations that you are allowed to view. We can check which options have been involved in every calculation. The selected scenarios and indicators. The applied functions and its parameters. The weighting values for every indicator. Once you select one calculation result for each user, the button Start Comparison will be activated. Clicking on it, you will be redirected to a page where the two calculations will be shown on the map, separated with a swipe tool. This tool allows you to use the pointer to swipe the map viewer from left to right, and vice versa. As you swipe to left, for instance, the calculation on the left side of the map will be temporarily erased, and the calculation on the right side of the map will be appeared, relative to the position of the pointer. You have the possibility as well to view the implemented indicator for each user and compare it side by side in this map viewer. The search box in the navigation bar let you type a text and find all the data which have to deal with that text. When you trigger a search for chloride, for instance, you're brought to a page which shows you the search result through all data types, document and spatial data.
In the top right of the screen, click on your username. A drop-down list will show. Click on Profile to enter the Profile Settings page, where you can manage your profile.
All the previous presented features and processes were done on the client site. The platform has additionally an administration interface, which provides a quick overview and management tool over the database. The content on the platform can be managed here, including project area, scenarios, indicators, default functions, layers, documents, users, groups and their authorizations,